We're going to end up covering 3 different methods for solving a system. We're going to start by the visual method, which is graphing. Now, graphing a system of equations on the same coordinate system, we can estimate the solution by looking for any point of intersection. But we need to keep in mind that unless we have an extreme level of precision, any solution we're going to get is an estimate, and we're going to want to verify the solution algebraically as we did above. So we can graph these equations, and it doesn't matter how you graph them, whatever method you want to use. We've been through many different ones, but we want to graph them and find where they intersect. So our first equation has a x-intercept or a y-intercept at 0, 2, and an x-intercept at 2, 0. So we can start by graphing our first equation. And then our second equation has a, let's see here, we can graph a y-intercept at 0, 2, and we have a slope of 1/3. And so when we graph these equations, we see that they have this common meeting point, this intersection, at the point 0, 2. 0, 2. And so with these two equations, they intersect, or it seems like they intersect at the point 0, 2. And my lines are pretty accurate, so that's a good estimate, but we need to check it. So let's check our solution, or our possible solution of 0, 2. We'll plug it into both equations and make sure we get a true statement on both. And since we do, then yes, that means that 0, 2 is our solution. We can go ahead and graph B. Our first equation has a y-intercept at 0 and a slope of 5. And then our second equation has a y-intercept of 7 and a slope of 1/2, or negative 2. And so we see this common intersection point at 1, 5. So that's our estimate. So let's check our estimate. All right, since both of those solutions work, then that means that 1, 5 is indeed our solution. Let's go ahead and graph the next one. So our first line has a y-intercept at negative 2 and a slope of 1/2. And our second equation has a y-intercept at 0 and also a slope of 1/2. And here we see that it appears that our lines are parallel. Well, since the solution to a system is where parallel lines intersect, and these lines are where lines intersect, and these lines are parallel, meaning they will never intersect, then that means we have no solution. Also, an empty set. Now we want to verify this, so let's go ahead and look at these equations, and let's put them in slope-intercept form. If we take x equals 2y, divide both sides by 2, we get y equals 1/2 x, meaning our slope is 1/2. And then if we take x minus 2y equals 4, and divide by negative 2, we get 1/2 x minus 2, and we see again that the slope is 1/2. So since the slopes are indeed equal, then we do know that is in fact no solution. So we want to be careful. Just because we don't see the lines intersect doesn't mean it's no solution. We do want to verify by confirming that they have the same slope. So now with the next equation, let's go ahead and also graph these. So we have a y-intercept at 2.5 and an x-intercept at 5. And if we do the same thing to the other equation, we find that we have the same x and y intercepts for x plus 2y equals 5. So they're the same line. Well, when they are the same line, then that means we have infinitely many solutions. And what we can do is say that our solution is all ordered pairs of x comma y such that, and then we give our equation. And we could write our equation in standard form, we could write our equation in slope-intercept form, but we're just saying that all points that exist on this line is our solution set because we can have any and all points and they are the same line. I want you to note that when we look at these equations, let's say x plus 2y equals 5, if I multiply everything in this equation by 2, what happens is I get this equation and we can visually see that they are the same. So this chart kind of summarizes the possible solutions to the systems. If we have one solution, we have a common intersection point. We call it a consistent system of independent equations. Independent meaning we have separate equations, consistent meaning we have a solution. No solutions are our parallel lines. It's an inconsistent system because we have no solution, and they are independent equations because they are separate lines. While an infinite number solution gives us a consistent system, there's a solution of dependent equations, meaning they are the same line.